Imagine the scene. You walk into a hospital lab for a routine test. A cold room, harsh white lights. Everything feels ordinary. You hand over a sample. You sit. You wait. But without you knowing, an artificial intelligence is already reading your DNA, live, in real time. And it finds something. A silent risk. A hidden genetic defect. Early signs of cancer. Clues pointing to Alzheimer's. Or mutations no one ever thought to look for. You feel nothing. There are no symptoms. But the machine already knows. It doesn't just analyze, it predicts. It understands what your body hasn't even realized yet. A silent scan revealing your biological future, not in weeks, not in days, but in seconds. Your DNA, once hidden in silence, now speaks directly to the machine, and the machine listens, decodes, and responds. You're not waiting for results anymore. You are the result, and the future of medicine has already begun. Welcome to CuriousVerse. What once took weeks or even months is now moving toward real-time execution. In 2017, the New York Genome Center and IBM tested Watson for genomics, an artificial intelligence system that analyzed the complete genome of glioblastoma patients, delivering clinical insights in minutes instead of hundreds of hours of human effort. Today, machine learning and deep learning algorithms are being used in precision oncology and in the diagnosis of rare genetic diseases. They're helping to detect tumor mutations, predict treatment responses, and interpret complex screenings faster and more accurately than ever before. Recent studies highlight the development of genome-based transformer models, systems trained to detect mutations by recognizing patterns in the DNA itself. These models are still being refined, but they hold the potential to transform genetic diagnostics in the near future. Across labs and research centers, AI is being applied to automate cancer triage, accelerate diagnoses, and identify hidden mutations with growing precision. We're entering a phase where the human genome is no longer just read, but interpreted by machines. To understand this breakthrough, we need to go back to where it all begins. DNA sequencing. Today, machines like the Illumina NovaSeq X can read billions of genetic fragments in just a few hours. It's like watching your DNA being typed, letter by letter, in real time. And right next to that machine is artificial intelligence, watching everything, line by line, code by code. For every single base read, A, T, C, or G, the AI cross-references it against massive genetic databases. It searches for patterns, rare mutations, and tiny variations called SNPs, the little errors that, on their own, seem harmless, but together might signal something dangerous. This AI was trained using millions of real genetic samples through supervised learning. It learned to tell the difference between a harmless variation, a mutation passed down through generations, and what could be a genetic time bomb waiting to go off. With every new exam, it becomes more accurate, faster, harder to ignore. The machine doesn't just process your DNA, it understands it. And maybe it understands it better than we ever could. Now imagine what this actually means. Diagnoses that once took months can now appear before the first symptom. Cancer, Alzheimer's, autoimmune diseases, identified years in advance. And that changes everything. Because we're no longer just treating diseases, we're predicting the body's future. With this level of genetic reading, personalized medicine is born, medications crafted specifically for your DNA. So see what medications destined for a decade perform opposite, leaving individuals without diagnosis, and medications crafted specifically for your DNA. Treatments tailored to your biological profile, nothing generic, nothing standard, everything uniquely yours. And it goes even further. Genetic algorithms are now being used in embryos, still inside the lab. They detect mutations before life even begins, and in some cases, they correct them. We're entering the era of real-time genetic engineering, a new generation that can be pre-selected or pre-enhanced. The question is this cutting-edge medicine or modern eugenics? But not every revolution comes without a cost. When artificial intelligence begins decoding your DNA, one inevitable question appears: who's in control? Your genetic code can reveal future diseases, mental tendencies, biological vulnerabilities. But does that information belong to you or to the company that tested you? If a health insurance provider gets access to your genetic profile, could they choose to exclude you, charge more, or deny treatment based on probabilities? And what if the AI is wrong, if it flags a mutation as dangerous when it's not? Who takes the blame? The doctor? The programmer? The machine? Behind the progress, a shadow grows, a new kind of selection, silent, invisible, genetic. Without realizing it, we may be paving the way for a future where lives are pre-approved or rejected before they're even born. While the world is still debating the present, the biggest biotech companies are already building what comes next. Deep Genomics, Genentech, Illumina, and DeepMind from Alphabet. They're in a race to master the most precious code in existence, the human genome. In June 2025, DeepMind launched Alpha Genome, an artificial intelligence capable of predicting how mutations affect gene regulation, including areas of DNA that were once complete mystery. But the next step goes far beyond reading. It's about rewriting. Researchers are now combining AI with CRISPR, a revolutionary gene editing tool that works like molecular scissors. It can cut and rewrite your DNA with surgical precision. What does that mean? It means the machine doesn't just find errors, it may soon correct them, in real time. DNA has always been our original code, but now, for the first time, the machine is learning to edit it. Before we even know what's wrong, DNA has always been our origin code, a silent alphabet, written in just 4 letters, A, T, C, and G. But now, the machine is learning to edit it before we even know something is wrong. If you've never stopped to think that an invisible code might define your life, maybe it's time to start understanding what's being rewritten, with or without your consent. Like, subscribe, and share this video, because what's at stake is not the future of technology. It's the manual of life. Yours.